Let's factor two terms. So first we'll do some warm-ups. 3x squared minus 7x plus 4, factor it completely. We multiply the a and the c. 3 times 4 is 12. And the bottom number of our diamond problem is negative 7. So we want two numbers that multiply to 12 and add up to negative 7, which are negative 3 and negative 4. So I replace negative 7x with those two terms. That's all I did. I uncombined my like terms. Then, since I have four terms, I can do factor by group. The first grouping, I can take out a 3x. I have x minus 1 left. Second one, I can take out a negative 4 because this first number is negative. And when I divide it out, I get x minus 1 as well. These need to be the same. So it's x minus 1. Cross those out. The leftovers, 3x minus 4. Letter B, same type of problem, except we have 0 for our B. So we multiply A times C. Negative 1 times 4 is negative 4. So we want them to multiply to negative 4 and add up to 0. Well, the only way we can get two numbers to multiply up to something and add to 0 is if they're the same but opposite signs. So negative 2 and 2. So I split up the 0x into 2x and negative 2x. I can always go backwards and change it. 2x plus negative 2x is 0x. And I'm back to my original problem. Here I decided to use the box. 4x squared, 2x, negative 2x, negative 1 in the box. Out of the first column, we can take 2x. By the second column, we can't take anything, but we can always take out a 1. First row, I can take out a 2x. Second row, I can take out a negative 1 because, again, this first one is negative. So we have 2x plus 1 and 2x minus 1. Letter C is just a GCF. You take out your 6x, you're left with x plus 6. There's no x squared, so we can't factor it anymore. X squared minus 2x minus 80. So we multiply the 1 times the negative 80, so it's negative 80. We want them to add up to negative 2, so it's negative 10 and positive 8. Again, I'm just splitting the 2x into, I'm uncombining like terms. So it's negative 10x and 8x. X squared and negative 80 are still the same. And then we group them. I can take an x out of the first group, I'm left with x minus 10. I can take an 8 out of the second group, and I'm left with x minus 10, which again is what I should have. These should be the same. So that's one part of our answer. The leftovers, x plus 8, is the other. All right, so there's two ways to think about factoring two terms. First of all, you always check for a GCF first. If we're doing it like this, like we're doing the other problems, we do 4 times negative 25 to get negative 100, and we want the sum to be 0. So we added this in because it wasn't in here. We were missing the b. So if we want two numbers that multiply to negative 100 and add up to 0, they have to have the same number, different signs. So 10 and negative 10. So I split it up into 10 and negative 10x. Again, I can always go backwards and get the same thing. 10x minus 10x cancels out with 0x. Now I take out my GCF. I take out 2x out of the first pair, negative 5 out of the second pair. So I have 2x plus 5s left, and a 2x minus 5 as our leftovers as well. So we can do it that way. Or this is called difference of two squares. Or dots. And what that means is if it's subtraction, which it is, and we can take the square root of both of these, which we can factor it that way. 4x squared, take the square root of that, that's 2x, and there's two of them because it is 2x times 2x to get 4x squared. And then to get 25, it's 5 and 5. So now I have them written twice. I write them twice again. 2x here, 2x in this other one, 5, 5, and then one's plus, one's negative, because it's a difference of two squares, but it's also different signs. (121 minus 81x squared). I can take the square roots of both of those, and it is subtraction. So I take the square root, I got 11 and 11, and 9x and 9x. So I have 11 minus 9x and 11 plus 9x. This next one is prime because it's addition. It's not the difference of two squares. There's no such thing as a difference for sum of two squares. So we can't go any farther. There's no GCF. It's prime. Next one, we can take the square roots of both of these again to get p and 13 and 13. So we write those each twice, one with a plus, one with a minus. Now we have some where we have GCFs first. We had a GCF of 3. Notice I took it out, then I drew an arrow to where my answer was going to be. Square roots of these numbers. Square root of 25b squared is 5b and 5b. Square root of 16 is 4 and 4, so we write those both. 5b twice, 4 twice, one with a plus sign, one with a minus sign. Number 2, there is no GCF, but we can take the square root of n squared, which is n and n, and take the square root of 4, which is 2 and 2. So we have n minus 2, n plus 2. Just the same two terms over and over again. We can take out a 4 here. We're left with 9x squared minus 16. I can take the square roots of those, get 3x, 3x, 4 and 4. So I still have my GCF of 4. Then I have 3x minus 4 and 3x plus 4 as well. Number 4, we have a GCF of 2. Then I can take the square roots of m squared, m and m, 4n squared, 2n and 2n. So I have m plus 2n, m minus 2n, and the 2 that was our GCF. Number 5, a squared minus 4b squared. We can take the square roots. There's no GCF. Square root of a squared is a and a. For 4b squared, it's 2b and 2b. So it's a plus 2b, a minus 2b. Last one, number 6, 4a squared minus 2b or 25b squared. We can take the square roots of those. So we have 2a twice and 5b twice. So we write them twice, once with a plus sign, once with a minus sign. And that's the difference of squares. So in general, a squared plus b squared, oops, not plus, minus b squared is always going to be a plus b times a minus b. The square root things written twice, one with a plus sign, one with a minus sign. And that's how you do two terms.